All right, so the next part of 5.3 is a new type of factoring. So this is brand new, and it is all formula based. So I'm going to kind of spell this out on this first example. And everything is based off of this formula right here. But the key is knowing and understanding perfect cubes. So I'm going to write over here the perfect cubes. Okay, 1 cubed is equal to 6, is equal to 1. 2 cubed is equal to 8. 3 cubed is equal to 27. 4 cubed is 64. 5 cubed is 125. And they start getting large pretty quick. Okay. 7 cubed is 343. And these are just numbers you need to be familiar with. 8 cubed is 812. 9 cubed is 727, I believe. Just make sure I don't screw that up. Yeah, 729. That's what I said. And 10 cubed is 1,000. Okay, and obviously these aren't the only 10. They go up, 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 and up. Now, the other thing you need to know is that if I were to take the cube root of 1, it would equal 1. If I would take the cube root of 8, it would equal 2. If I take the cube root of 27, it would equal 3, and so on and so forth. So when I talk about these certain values, 27 is a perfect cube because when I take the cube root of it, it equals 3. 125 is a perfect cube because when I take the cube root of it, it equals 5. So now, looking at this formula, we're going to kind of write and spell this out. Okay, so if I have a cubed plus b cubed, first of all, understand these have to be perfect cubes. Well, what makes a variable a perfect cube is if it's a factor of 3. So 3, 6, 9, any of those variables being raised to those exponents are perfect cube. So you can have x to the 9th plus, and then any of these numbers here are my perfect cubes. So we have the formula. It always factors to a plus b. And I'm going to kind of spell this out. How do I go from a cubed to b cubed? I take the cube root of the first term, okay? How do I get b from b cubed? I take the cube root of b, okay? So we're going to take the cube root of the second term. Sorry, I'll say second term, okay? The sign is always the same. So we have to create a binomial with what we're given. Then I'm going to create a trinomial. Okay, the trinomial we get from everything from the first binomial that I just created. So we're going to take a squared. We're going to square the first term of the binomial. And this is me just spelling it out just so you know where I'm getting these from. We change the sign. Okay, we're going to change the sign. We're going to multiply a times b. Okay, multiply a times b. Where did I get a times b from? It's this number and this number. I do not worry about the sign. The sign is already taken care of. So let's say this was 10 minus x. I would multiply 10 times x, and the sign is taken care of. And then I'm going to add b squared, which is square the last term. Okay, so square the second term in the binomial. That's how it factors every time. So in the given example, I've got x cubed plus 8. This is going to factor to a binomial times a trinomial. How do I get the first term? I take the cube root of the first term. The cube root of x cubed is just x. Okay, so take the cube root of the first term. There it is. I keep the same sign, so plus. What's the cube root of 8? The cube root of 8 over here is 2. Now, once I have this, it's based off of this binomial. So to get the first term, I'm going to square the first term. Well, x squared is x squared. I'm going to change the sign. I'm going to multiply a times b. I'm going to multiply x times 2 or 2 times x and get 2x. Here's where you have to pay attention to the formula. I know 2 times x is positive 2x. but the formula tells me to change the sign. So it's a minus 2x, and then I square the last term. 2 squared is 4. This is completely factored. Okay, this is called the sum of two cubes. The nice thing is, the only thing that changes for subtraction is minuses. Okay, the only thing that changes for subtraction is the sign. So instead of this being a plus right here, this would be a minus, and instead of this being a minus, it would be a plus. Everything else stays the same. We get the math the same way. So let's take a look at a couple of examples. Okay, I've got t cubed plus 64. Again, it's going to factor to a binomial times a trinomial. I'm going to take the cube root of t cubed, which is just t. Keep the same sign. Take the cube root of 64k cubed, which is 4k. Now I'm going to get this trinomial from the binomial. Square the first term, t squared. Change the sign. Multiply 4k times t, which is 4kt. And then square the last term. Remember to square the number and the variable. 4 squared is 16. K squared is k squared. This is completely factored. Once you get the hang of the formula, it goes really, really, really quickly. Okay. Now this is subtraction, and there's a couple of things. I'm going to go ahead and write the formula for subtraction up here. I'm not going to spell it out, but if I have a cubed minus b cubed, okay, and that's the given problem, a cubed minus b cubed, that's going to factor to a minus b, and then that will be a squared plus a times b plus b squared. This is always a positive because I'm squaring it. And when you square a negative, it still becomes a positive. So here, same thing. I'm going to get a binomial times a trinomial. I'm going to take the cube root of 64, which is 4. The cube root of t to the 6 is t squared. Keep the same sign. The cube root of z to the 6th is z squared. And again, why is that? Because z to the 6th means there's 6 z's, right? When I take the cube root, means I need groups of 3 to be able to simplify, and I can take 2 groups of 3. Now this trinomial we get from the binomial. Square the first term. 4 squared is 16. T squared squared is t to the 4th. Change the sign. So plus, multiply 4t squared times z squared gives me 4t squared z squared, and then square the last term, which is z to the 4th, and that would be completely simplified. Once you do this factoring, the sum or difference of two cubes, this trinomial can never, ever, ever be factored. You're done. Okay, so that will be it for the sum or difference of cubes. You're going to have a few of those. Give them a shot. The next thing we're doing is factor by grouping. The way that I try to tell kids to factor by grouping is look and see if you have how many terms you have. If you have 4 terms, okay, then you're going to factor by grouping. And all we simply do is factor. We group the first 2, group the second 2. Okay, so the first step is to group first 2 terms and the second 2 terms and the last 2 terms. Okay, so that would be the first thing that we do. So that's number 1. Number 2, we're going to take out a GCF for each one. GCF for each group. Okay, so I'm going to take out here an x squared. It's going to leave me with an x minus 2. Here I'm going to take out a negative 9. It's going to leave me with an x minus 2. Okay, here I should have the same thing in the parentheses. If I don't, I did something wrong. Okay, so I do. So now I'm going to factor out what's in the parentheses. So I'm just going to write it down once. So what's in the parentheses? X minus 2 and x minus 2. So I'm going to write down x minus 2 once. So I'm basically dividing each of these by x minus 2. And what does that leave me with? It leaves me with x squared minus 9. Then the fourth thing I do is factor if I can. Okay, factor more. I'll just say. I can't factor this. X minus 2 is x minus 2. But this x squared minus 9 is the difference of 2 perfect squares. So that factors to x plus 3, x minus 3. Okay, so again, this is kind of how we do this. going through this step by step. It's kind of sloppy here, but factor the first two terms. Group them. Okay, well, what do they have in common? It looks like an x squared. So I take out an x squared. It leaves me with y squared minus 3. Factor out the GCF, looks like a -4, which leaves me with y squared minus 3. I know that I'm doing this right because what's in parentheses is the same. Has to be if you're doing this right. So now I take what's in parentheses and I write it down once. Whatever was not in parentheses, I group together and put it in its own set of parentheses. So there's the x squared. There's the -4. And then now, can I factor any more? Yes, I can. This factors to x plus 2, x minus 2. And that would be the end of the factoring by grouping. So again, factor by grouping is when you have 4 terms. So make sure that you pay attention to those. Okay, so the last thing in this section is some multi-step factoring where we kind of combine everything that we've done. So the first thing I want to look for is a GCF. In this problem here, you see the GCF is a 3x to the third. So what I'm doing is I'm dividing each of these by 3x to the third. So I'm going to take out a 3x cubed. And I'm dividing each of these by 3x cubed. Again, make sure these are set equal to 0 and then solve them. So when I do this, I am left with a 4x plus, right? 12 divided by 3 is 4. 4x's minus 3x's is just x. So I'm left with a 4x plus 21 divided by 3 is 7. My x cubes cancel. Now, they don't cancel. They're really right here. So, again, I should be able to distribute this and get the same thing back, and I would. And then now I'm going to use the zero product property. 3x cubed equals 0, and 4x plus 7 equals 0. So to solve this, I divide by 3, and I would get x cubed equals 0. Take the cube root, and I would just get x is equal to 0. This is a multiplicity 0 that I'm talking about from last chapter. So last section equals -7, divide by 4, and you get x is equal to a -7 over 4. So again, here's 1 0, here's 2 zeros, but it actually counts as 3 because it's cubed. So we have 1, 2, 3, and 4 zeros, and I get 4 zeros because it's raised to the 4th power. Okay, this problem here, if I could take a GCF out, I highly recommend that you do it. In this problem, it can get a little bit ugly here, but I can take out a 2x cubed for every single one of these problems, right? That would leave me with x to the third minus 4x squared plus 2x minus 4. And then now I've got 4 terms in parentheses, so I'm going to factor by grouping. I'm going to ignore this to the end. Okay, I'm going to ignore that to the end. It's part of the problem, but I'm going to ignore it to the end. So what do? I group the first two. I group the last two. Take a GCF out. Okay, so I've got an x squared, which would leave me with x minus 4. I've got a 2. Hold on a second. What did I do? Nothing. I factored this 2 out. That shouldn't be there. This is just an x. I took that out, right? That's just an x. How did I know that I did something incorrect there or had something written wrong on my paper? Because what I get in parentheses has to be the same. Okay? What I get in parentheses has to be the same. So when I took a 2 out here, I need to divide this by 2, and it leaves me with just an x. So now this is a really good point in grouping. Okay, if it's already the same, well, what can I factor out that doesn't change any value? And I can take a 1 out. So if I get the same thing in parentheses or I have the same thing in parentheses, I still want to factor a 1 out. So now that would leave me with I'm going to drop this down now, 2x cubed times x squared plus 1 and an x minus 4. So I write down what's in parentheses once and I group together what's on the outside. Okay. So then now if I was solving this and I was writing all the real zeros, this would be 0. This would be 4. Okay. And then this x squared plus 1 would be x plus I, x minus I, which would be negative I, positive I. And I think I got only real solutions for the homework for today. But again, here's 3 zeros, 4, 5, 6. I had a 6th degree polynomial to begin with. So there's some problems like that. Give them a shot. These problems will get a little tougher. So if you've got any questions, make sure that you're asking.